All right, so today we're diving headfirst into a scientific treasure hunt, and our map is this incredible research paper that follows a team of mathematicians looking for a number that's supposed to be everywhere but has completely vanished. So let's grab our gear and get started.
It's a pretty deep question when you think about it. If a number's truly universal, shouldn't it pop up everywhere we look? Well, that is the central mystery we're exploring today, a puzzle buried deep inside a strange and, frankly, beautiful mathematical landscape.
Here's how our expedition is going to break down. First, we'll get to know the missing treasure we're hunting for. Then, we'll look at a secret clue that promised to reveal its location. We'll see how the scientists made sure their new tools were working, and then we'll join them on the actual hunt. And finally, we're going to talk about why finding an empty treasure chest can sometimes be the biggest discovery of all.
Every great treasure hunt starts with a legend, right? And in this corner of the math world, the legend is all about a universal constant, a fundamental number that is just gone missing. This is our treasure. The treasure has a name. It's called a Feigenbaum pole. The easiest way to think about it is like pi, but for a very specific thing, the moment when a nice, orderly system descends into pure chaos. This number should be a universal signpost, popping up all over the place. The big problem? In one specific landscape, it's nowhere to be found.
And that landscape is a territory known as Class C. Now, other explorers have been here before. Previous studies, specifically papers 18 and 19 in the literature, scoured this area. They looked everywhere, but the Feigenbaum pole was just invisible. Its absence was a real, nagging puzzle for scientists.
But then, a new clue surfaced, a kind of secret key, pulled from a totally different and wonderfully named field of mathematics that just might make the invisible visible.
And yes, you absolutely heard that right. The clue comes from alien calculus. Now, this isn't about little green men or anything. It's a seriously deep and powerful branch of mathematics. And from this calculus, they derived a tiny, super precise adjustment, an alien correction, that they hoped would work like a special pair of glasses, letting them finally see the hidden pole.
Now, get a load of this. Look at that number. That's the size of the correction. We're talking about 6 parts in 10 billion. It is an unbelievably, almost unimaginably small tweak. So the big question on everyone's mind was, could a change this tiny really be enough to solve such a massive mystery?
So the whole new strategy is right here on this slide. On the left, you've got the original data from Class C, the data where the pole was totally invisible. And on the right, that's the same data, but it's been nudged just a tiny bit by that alien correction. The entire hope of this new search rested on this one minuscule change.
Okay, so before you go trekking into the wilderness for a real treasure, you have to make sure your map is right and your compass isn't broken. That's exactly what the team did next. They had to test their new tool.
And the way they did it was really clever. First, they built a synthetic test course. They basically created a set of data and manually hit a fake pole inside it. They knew exactly where the treasure was supposed to be. Then, they unleashed their new alien-corrected tool on this fake data. And the result? Bam! It found the fake pole with perfect accuracy.
The test was a huge success. It was the proof they needed. Their compass worked. If a Feigenbaum pole was there to be found, their new method was definitely sensitive enough to spot it. So with confidence running high, it was finally time for the main event.
All right, this is it. Armed with their newly calibrated tool, the scientists went back to that mysterious Class C landscape. The hunt was officially back on.
And let me tell you, this was no casual search. They were incredibly thorough. Just look at the parameters here. They analyzed tons of data and looked at it through all these different mathematical lenses. You can think of these Borel scales and Padé degrees as different ways of focusing their microscope to get the absolute sharpest image possible. They aimed all this firepower at the one spot, the alien strength ladder, where the correction should have made the biggest difference.
So after all that preparation, all that testing, all that intense searching, this was the result. In the paper's own words, nothing. No staple Feigenbaum pole showed up. The treasure chest was empty. The universal number stayed hidden.
This table from the paper just hammers the point home. It wasn't like they only looked in one spot. They checked several different pathways through this landscape: the orbit multiplier, the WBA ladder, and of course their new and improved alien ladder. And you can see it right there on the right, across the board in the exact window where the pole was supposed to be. The result was the same. None detected, negative, negative.
So, was it all just a big failure? Not even close. Because in science, finding nothing is often just as important as finding something. It means you might have found an empty chest, but you walked away with a much, much better map.
And here's the real takeaway. The fact that they found nothing is actually evidence of something really complex going on. It proves the pole is hidden in Class C not because of some simple mistake, but because the landscape itself is so incredibly intricate that it can completely swallow a universal constant. The mystery is real, and it's buried way deeper than anybody thought.
So, what did this whole expedition teach us? Well, we learned that Class C is genuinely Feigenbaum-blind, at least to the tools we have now. We learned that a simple, first-order alien correction, as clever as it was, just isn't powerful enough. This result forces the next wave of explorers to develop even more advanced maps, maybe using higher-order corrections, or even shifting the search to a totally different continent, like Class B. This isn't an ending, it's a signpost for the next adventure.
And that leaves us with this final, really fascinating question to chew on. What does it actually mean when something we think is fundamental, something that should be universal, can play hide and seek this well? It suggests that there are rules hidden beneath the rules we thought we knew, and maybe the most valuable treasures aren't the ones we find, but the ones that show us just how much of the map is still waiting to be explored.